I don't want to be here. I don't want to do this right now. And I straight up still don't do complexity analysis before I leave. Okay. This is the one that I was struggling with. What's going on here? So we're back. I'm here to do complexity analysis of the last problem we did. I'm also kind of hungry, but I know right now, if I eat food, I'm not gonna work on this anymore. So I need to avoid ordering anything. I'm gonna just write. I don't know why I write complexity. I'm writing time complexity. I don't care. Okay. So this is the problem where we had to get the longest substring with k replacements. The longest, I guess, homogeneous. Yep. I said homogeneous. Longest homogeneous substring with k replacements. I keep checking my phone for no reason. I'm hungry. I think I'm hungry. I can't really tell. But I'm trying to also not eat mindlessly, but as a loop over the string. And then space complexity is what? 1 as we can only okay. So moving forward, last time I probably spent an hour on two. I probably spent an hour each on 2 problems, and that is slow. Ideally, I should be able to get through a hard, easy, or medium problem within 45 minutes to an hour. Now that sounds like, okay, well, you did that, but the reality is I want to do it faster. Let me just state that for the record. I want to do it faster. So this is longest array with 1s as replacement. So this replacement thing seems to be a theme, I guess. That's weird. Why did I do that? So the goal right now is to spend 45 minutes on the problem, or 40 minutes on the problem. If I can't solve it after 40 minutes, then I'm going to look up the solution. The reality is that to get better at this, you have to expose yourself to more stuff. The reason why the last problem was so hard was because I did not know how to put in words this piece of logic here. I understood that there was good, like that you had to know. You had to know something about the replaceable characters, but I just couldn't figure out what it was. I think that the more I expose myself to things, then the faster I'll get through problems. But I do want to spend time thinking about it and trying to come up with a solution before I just try to just get the solution. All right. So, given an array containing 1s, 0s, and 1s, you are allowed to replace no more than k zeros with 1s. Find the length of the longest contiguous subarray having all 1s. So this sounds really similar to our last problem, in that if I have an array, going to the whiteboard here, in that if I have an array of 1s and 0s, I use the first example, we need to replace no more than k So we're really trying to get the longest substring of zeros because we're trying to replace no more than k zeros with ones. Oh no, so we need the longest substring of ones. Okay. This is kind of similar to our last problem in that we need a way to track, sort of when we're out of replaceable characters. So we can continue, let's see. So without going into dictionaries or window adjustment triggers, let's talk about how we solve it, plain out loud. So as I'm looking at each number, right, 0 or 1, I'm going to try to find the longest substring. Okay, so our window has to start at the first 0, and our end, when we're just starting out, will be also at that 0. Since we know that we're going to be replacing zeros with ones, right? If I add a 0, the longest substring here would be a 1. If I add a 1, it'd be 2. If I add another 1, it'd be 3. Because it's at most k replacements. If our substring goes longer than that, the longest one we have is 4. Now, why is that? Because if we keep track of the number of ones we have, right? So let's say we have a tracker, num, but num of ones. Currently we're at 2. The length, or well, I'll say, yeah, no. Window length is equal to our end minus our start plus 1. So when we're at the fourth or the third index, that second 0, we're at index 3 minus our start are still pointing to 0. So we have 4 characters. So our length right now is equal to 4, right? And our window needs to adjust when we're greater than k. So basically the same thing, right? When we do 4 minus 2, so when our window length minus the number of ones we have is greater than k, we then need to adjust our window. So if we did that, right, let's say we got to this third 0, we would, first of all, adjust our window. So we push our start to the first 1 or index 1, and then we would continue to add the 0. Let's walk through it again. Okay. So if n minus start plus 1 minus num of ones, greater than k, then move our slider window around. So I'm adding a 0. Okay, so let's talk about tracking then. We don't need a dictionary to track. In the last equation, we had a dictionary to track what? The count of, because it could change, right? Because the character with the highest repeating number, or what I say, with highest repeating letter count could change. We're never going to track zeros. At least not directly, we're tracking ones. So we want to know at any given time, as we begin to add characters to this, So we'd increment our number of ones if it's a 1. If it's not a 1, then what? We don't increment it. Okay. So let's keep track of the number of ones we have. As we're moving through this, we have a tracker for the number of ones. And so we have our first 0, not a 1. Cool. Which means that, so if we have a 1, we increment our tracker. We're really looking for a way to slide our window and update our max. We want the length of the longest string. So our max will be the max between our historical max and a complete and replaceable subarray. So for example, let's say we don't have to adjust our window. Our max length, our new max length would be something like, well, I'm guessing end minus start plus 1. Right? Because that would give us 0 minus 0 plus 1. That new max is now 1. If we add a 1, right, our start still points to 0. We add a 1. We don't adjust the window at all. And we now say, cool, our new max is 1 minus 0, which is 1 plus 1, 2. That's now new max is 2. We add another 1. We now have 2 1s. Okay, end minus start plus 1 minus number of 1s is, what is that? Our end is at index 2 minus 0, 2 plus 1 is 3. So 3 minus 2 is not greater than k, right? 1 is not greater than k. So now our end is now, our new max is now 3. Okay, it was at 1, it's at 2, now it's 3. Sweet. We added another 0. Okay, it was not a 1, it's a 0. What does that mean? Well, let's take a look. If 4 minus 0 plus, no, 4? If 3 minus 0, which is 3 plus 1, which is 4, minus 2 is greater than k. Not greater than k. No need to adjust the window. So then we have 4 as a longest subarray. Cool. Let's see. If we were to add our index, our fourth, what is this? 0, 1, 2, 3, 4. Index 4, or our third 0. Number 1 stays the same. Our end is at index 4. So 4 minus 0 is 4, plus 1 is 5. Minus 2 is 3. That means we have 3 replaceable characters. And in our last equation, our last problem, the goal wasn't to shift our window around. We're not using any tracking, by the way. So our start gets bumped up to 1. At least, that's for sure. So now we're pointing to our first 1, or index 1. Is that all we have to do? Let's check. Our start's now at 1, which means now we do index 5 minus 1 is 4. Okay, plus 1 is 5. That's not valid, right? Did I do that right? Oh. Yeah, it'd be 5. No. What? Oh, what? So our start is now 1. It'd be, we have index 0, 1, 2, 3, 4. Oh, 4. Okay. So as long as we had still 4 minus 1, 4. Nothing changed. Cool. So because we moved our start, that was valid. Great. We bump up again, index 5. That's our end. Start points to first 1. We're in another scenario. We added another 0. Our index is 5, right? Our end index 5. Start is 1. That's 4. 5 minus 1 is 4, plus 1, 5. Minus, still, we only have 2 1s. Okay. We have 2 1s. Okay, what we didn't do, what did I just do? Restart. 5 minus 1 is 4, plus 1 is 5. Minus 2, 3. So we have 3 replaceable characters. We have the 3 zeros, the index 3, 4, and 5. Now what? We need to bump our start up again. Cool. Now our start points to the second 2, or the second 1, or index 2. And what I'm noticing is that we need to also decrease the number of 1s we have. So we'd say num of 1s minus equals 1. If our starting number is, so if start, I'll say is 1. I'm not gonna do is 1, but I'll just say is 1. Then num of 1s minus equals 1. Move our 1. We move our point. Move the decrease of 1s down to, okay, cool. Excellent, excellent, excellent. Now what do we have? our start now points to 2. Now we have index 5, minus 2 is 3, plus 1 is 4, still 4. Sweet. We add another 1. Great. We add another 1. Sorry, now our count is now back up to 2. Okay, index is now 6. So 6 minus 2 is 4. Plus 1 is 5. Minus 2 is 3. We're going to move our start, therefore, to our second index 3, or second 0. Then we're going to say if the start was pointed to a 1, and it decreased. Now our code right now moves the start without first grabbing the number. So we have to first grab that number. So say like, I'll say left num equal to, I'll say like array at start. First we grab that, right? I'll inject that in there. We have to grab that first and then do our start. Say left num start, and inject that up there. Cool. Okay. Our starting point's there. Was that a 1? Yes. So decrease this back down to 1. Cool. So our start is at 3. Our end is at 6. 6 minus 3 is 3, plus 1 is 4. 4. Sweet. We move on again. Index 7. It's a 1. Our 1s are back up to 2. So 7 minus 3 is 4. Plus 1 is 5. Minus 2 is 3. Does that make sense? Yes, we have 3. We have too many zeros. Need to adjust this. Then our start was not a 1. So we just move our start pointing to now index 4. Okay. Then we do 7 minus 4 is 3, plus 1 is 4. Our max does not change. Cool. We add our index 8. It's not a 1. We don't move the 1. We still have 2 1s in our window. 8 minus 4 is 4, plus 1 is 5, minus 2 is 3. So then, and our start is not a 1. We move our start. Our start is not a 1. Move that to 5. Then we do 8 minus 5 is 3, plus 1 is 4, doesn't move, sweet. We add a 1. Okay, index is now 9. We now say it is a 1, so now we have 3 1s. And we say 9 minus 5 is 4, plus 1 is 5. Okay, minus 3 is 2. This is legit. Then we do 9 minus 5 is 4, plus 1 is 5. Our new max is 5. Sweet. We add another 1 to our end. Okay, that's now 4 1s in our window. So we have index 10 minus 5 as our start. That's 5 plus 1 is 6. 6 characters total. Minus 4 is not greater than k. Our start is not pointed to a, so we don't bother with this if statement. We then say, okay, 10 minus 5, 1, 6. Now it's 6. End. Does that make sense? Cool. Okay, let's do another example to make sure this is solid. If I solve this early, I'm about to go get food because I'm hungry. If I solve it early, I probably should do the next one because it'll get me ahead faster. But if I wait too long to eat, guys, I'm literally gonna be so bloated when I go there, and we're gonna have to eat dinner tonight. So if I go feed myself with $10-12 meal, buying Jasmine and Carla food, but they're also leaving tomorrow, so shouldn't be too big of a deal. Let's see. should eat, but I'm kind of full on water, so we'll see what I end up eating. Okay, let's take a look. I'm gonna rewrite my code as well, be more legible. Right. So the point is to say if end minus start plus 1 minus num of ones greater than k, then we store our left num from the array at start. Then we say start plus equals 1. Then we say if left num equal 1. Then we say num of ones minus equals 1. Sweet. Another example. 0 1 0 0 1 1 0 1. Huh? 1 0 0 1 1. Cool. A lot of numbers. Damn. With k being 3. Our expected output is 9 again. All right, we add our 0. That's a 1. We add a 1. It's now a 2. We add another 0. It's now 3. Add another 0. It's now 4. Excuse me. Add another 1. Now 2 1s. Okay. So now we're now at index 4. Okay. We have 2 1s in the window, 3 zeros, 3 replaceable characters. 4 minus our start pointing to 0 still. 4 minus 0 is, so we have 5 characters. Minus 2 is 3, which is not greater than k. We move on. So we just have 4 minus 0 plus 1 is 5. Cool. We add another 1. Another 1 is now 3. So now we have 4. What did I say? No. We now have 5 minus 0 plus 1 is 6. Minus 3 is now 3. So we're still good. That's now 5 minus 0 plus 1 is 6. Okay, cool. New max is now 6. We add another 0. It's cool. Now we have 6 minus 0 is 6 plus 7 minus 3 is 4. So then we have our number of zeros or replaceable characters is greater than k, greater than what we're allowed to replace. So we need to slide our window over 1. So our left is a 0. Move the start up 1. The left character is not. The left character is not a 1, so we don't touch the number of 1s count. Then we take our end, which is currently pointed to 6. We do 6 minus 1 is 5, plus 1 is 6. Cool. Now move over to index 7. It's a 1, and we have 4 1s in the window. Right, 1, 2, 3, 4. That's 4 1s. So now we take 7 minus 1 is 6 plus 1. 7 minus 1 plus 1 is 7. Minus 4 is 3. Cool. Now we have, again, 7 minus 1 plus 1 is still 7. New max is 7. We add another 1. That's now 5 1s. Index 8 minus 1 is 7 plus 1 is now back to 8. Minus 5 is 3. Cool. Our new max is now 8. We add a 8. We now add a 0 to the list. So we're at index 9. It's not a 1, so we don't touch number of 1s. 9 minus 1 is 9 minus 1 plus 1 is 9. Minus 5 is 4, greater than. We're currently pointing to a 1. So number of 1s is down. Our start to down to 4 from 5. Our start now points to a 2. We now say 9 minus 2 is 7. It's plus 1 is 8. So we still have 8. Sweet. We add another 0. That's 10. Minus 2 is 8. Plus 1 is 9. 9 minus 4 is 5. Greater than that. So we're going to move our start. It's not a 1. So we're going to just do now 10 minus 3 is 7. Plus 1 is 8. Cool. So our max is still at 8. Bump over 1. Index 11. We added a 1. We're back to 5 ones. So we have 11 minus 3 is 8. Plus 1 is 9. Minus 5 is 4. So we have 1, 2, 3, 4. Yep, we have too many K's or too many zeros. So we're going to move our start over to index 4. It's not a 1, so don't touch the number of ones counter. Then we have now 11 minus 4 is 7. Plus 1 is 8. So our max is still 8. Sweet. We add another 1 at 6. 6 ones. We now take index 12 minus our start at index 4, which is 8. Plus 1 is 9. Minus 6 is 3. Therefore, we have a new max at 9. I think this solution works, guys. I think this solution works. Let's code it up and go get some food because I'm starving. Let's do a code explanation because I got time. We're going to solution explanations. What do we do? So I'm going to say using a num of ones tracker and a current max tracker, right? I didn't put that in the code in my pseudocode, but it's there. As well as end and start. I'll say we iterate over the list of numbers, incrementing our count of, I'll say incrementing num of ones if we see a 1, and adjusting our window by 1 if end minus start plus 1 as num of ones is greater than k. Basically, that means we have more than k replaceable zeros in our window. We then need to increment our start, and if the start was pointing to a 1, we'll decrement our num of ones. Then we lastly update our max length with the max of max length versus end minus start plus 1. Yay! Hopefully this actually runs properly. I kind of had a solution for it, but I didn't really. I was doing a frequency map. I mean, they built these problems built on each other, so there's a reason why they showed us that problem before this one, right? I could be dashing. I'm not though. Crazy. Crazy. I'm looking at my phone for no reason. Stay focused. Oh, Avatar's coming out when? December 16th. I did not want to watch that movie. It looked like absolute trash. Which is harsh. You know how it is. So the array, the list of type int and k is also an int on its own. The code is to have a start. And what else? Both at 0, we'll say for end in range length of the array there. Say if, we'll say new num. New num gets array at end. We say if new num equal 1. Then we say num of ones plus equals 1. We say if if end minus start plus 1 minus num of ones greater than k. I'm gonna add another parenthesis around this. And what we do, take our start. I'll call it current start. I'll say current start gets array at start. I'll say if cur start equal 1. I want number of ones to be decreased by 1, and our start to be incremented by 1. But only after the fact. Then we do our max calculation. Oh yeah. How about that? If the max length is max between the old max length and end minus start. This one. Return max length. Right? Okay, then we add our our testing framework tests. I'll say we'll test that. Type ints, list of ints. Also an int. Also pass in the expected output. Cool. And we just, I forgot to add my thing. Well, I can do that too. So assert that length of my substring array and k equal expected at pytest.mark.parameterize. And we'll say this is array and k expected, and pass in our tests here. We'll also add a ipytest.run method call. We'll give it this array of ints. It looks like k equaling 2, and the expected is 6. I'll give it the other array of ints. K is equal to 3, expected is 9. All right. Let's take a look here. Gang, brothers. I'm gonna upload that. And I'm going to go eat food because it's 1 o'clock. That took a lot longer than, or took shorter than I thought it would. So I'm gonna over myself with some food. I'm really craving Lian Chen or something. I don't know why. Even though I really have no interest in eating that, I'm just like some nice like firecracker shrimp or the honey walnut shrimp from Panda Express. It just sounds really good right now. I don't really know why, but we're gonna go get that. I think. Oh, well that's fine. Yeah, it's fine. GitHub. Let's clear out output cells. Okay. And before I leave, I'm gonna do complexity analysis because I always forget. All right. This is also O(n), and this is also O(1). Okay. Let's add that. Okay, I'm out of here.